Ladies and gentlemen, for decades, American manufacturing thrived on a simple assumption that global supply chains would always remain open, predictable, and efficient. That assumption is now being tested. Today, the story unfolding before us is not just about Tesla, not just about silver, and not just about China. It is about a deeper vulnerability in the U.S. manufacturing system, one that has been quietly building and is now impossible to ignore. When a single policy decision thousands of miles away can disrupt production lines in America, we are no longer talking about trade. We are talking about national economic resilience. Silver is not a luxury commodity. It is a strategic material. It powers electric vehicles, solar panels, advanced electronics, and next-generation batteries. Every modern clean energy ambition depends on it. When access to silver tightens, innovation slows, costs rise, and competitiveness erodes. Tesla, one of America's most advanced manufacturing success stories, depends on highly refined silver for its vehicles and energy systems. When supply becomes uncertain, even the most technologically sophisticated companies are forced to pause, rethink, and absorb costs that ripple across the entire economy. For most of modern economic history, power was measured in factories, labor, and capital. Today, power is increasingly measured in access to materials that make advanced technology possible. Silver has quietly moved from being viewed as a traditional industrial input to becoming a strategic asset with geopolitical significance. It is embedded in electric vehicles, renewable energy systems, semiconductors, medical technologies, and defense electronics. Without reliable access to silver, entire sectors central to economic growth and national security slow down or stall. What makes this shift so consequential is not scarcity alone, but control. The countries that dominate the refining, processing, and export of critical materials now possess leverage that extends far beyond markets. They can influence production timelines, raise costs for competitors, and reshape industrial priorities through policy decisions rather than direct confrontation. In this environment, trade policy becomes a strategic tool, and supply chains become instruments of influence. For manufacturing nations, this reality demands a new way of thinking. Strategic materials are no longer neutral commodities traded purely on price and availability. They are foundational to innovation, competitiveness, and technological leadership. When access is uncertain, long-term planning becomes fragile. Investment decisions are delayed, research timelines stretch, and industrial confidence erodes. This shift also exposes a fundamental imbalance in the global system. While consumption and innovation are spread across many countries, control over critical inputs is concentrated in very few. That concentration transforms materials like silver into pressure points that can be activated during moments of economic or political tension. The result is a world where manufacturing strength depends not only on engineering excellence, but on geopolitical positioning. Understanding silver as a strategic resource is not alarmism, it is realism. In a technology-driven economy, the materials that enable progress define the limits of power, independence, and resilience. China's use of export controls has revealed a structural weakness that has long existed beneath the surface of U.S. manufacturing. For years, global supply chains were built on the assumption that efficiency, scale, and cost reduction were sufficient safeguards against disruption. That assumption depended on uninterrupted access to materials processed far beyond U.S. borders. When China introduced tighter export requirements on strategically important materials, it did more than adjust trade flows. It exposed how limited American control has become over the inputs that sustain advanced manufacturing. The vulnerability is not rooted simply in where materials are mined, but in where they are refined, processed, and certified for high-technology use. China's dominance lies in its capacity to transform raw materials into industrial-grade components required by electric vehicles, electronics, and renewable energy systems. When export licensing or regulatory delays are introduced, U.S. manufacturers face uncertainty that cannot be resolved quickly or cheaply. Alternative suppliers often lack the same scale, technical specialization, or regulatory readiness to fill the gap on short notice. This dependency creates cascading effects across the industrial ecosystem. Manufacturers must revise procurement strategies, absorb higher costs, or delay production schedules. Investors respond to uncertainty by demanding higher risk premiums, while long-term planning becomes increasingly fragile. The impact extends beyond individual companies to entire sectors that depend on predictable material access to maintain innovation cycles and global competitiveness. What makes this exposure particularly concerning is its asymmetry. China can adjust export policy as a sovereign decision aligned with domestic priorities, while U.S. firms must react within market constraints. This imbalance limits strategic flexibility and reduces the ability of American manufacturers to respond independently to geopolitical shifts. In practice, economic policy decisions made abroad can influence production outcomes at home without direct negotiation or confrontation. The situation also highlights a broader policy gap. While the United States has emphasized technological leadership and clean energy transformation, it has invested far less in securing the upstream foundations that make those goals achievable. Supply chain resilience was treated as a secondary issue rather than a strategic imperative. Export controls have now turned that oversight into a visible risk. This exposure is not temporary, nor is it limited to a single country or material. It reflects a global competition in which control over processing capacity carries as much weight as control over innovation itself. Recognizing this vulnerability is the first step toward redefining manufacturing strength in a world where access, not just invention, determines economic power. The assumption that scale and technological leadership provide immunity from supply chain shocks has proven increasingly fragile. When a company as large and globally integrated as Tesla encounters material access constraints, it sends a clear signal that size alone no longer guarantees resilience. Tesla represents the upper tier of American manufacturing, capital-rich, technologically advanced, and strategically important. If such an enterprise must adapt production strategies due to material uncertainty, the implications for smaller manufacturers are far more severe. Large firms often have advantages that others do not. They can negotiate long-term contracts, diversify suppliers, invest in redesigns, or temporarily absorb higher costs. Even with these advantages, disruptions in access to critical materials force trade-offs. Production schedules are adjusted, research priorities are reconsidered, and expansion plans are delayed. These are not minor operational inconveniences. They shape corporate strategy and influence the pace of innovation across entire industries. For mid-sized and smaller manufacturers, the challenge is amplified. These firms operate with thinner margins, fewer supplier alternatives, and limited bargaining power. When material access tightens or prices rise, they are often forced to reduce output, pass costs to customers, or exit markets entirely. The result is consolidation, reduced competition, and a weakened industrial ecosystem that becomes increasingly dependent on a small number of dominant players. The broader economic consequence is a narrowing of manufacturing capacity and diversity. Innovation thrives when multiple firms experiment, compete, and specialize. When supply chain pressure eliminates smaller participants, the system becomes less dynamic and more brittle. This concentration increases systemic risk, as disruptions affecting a few large firms can ripple across entire sectors with greater intensity. The situation also challenges long-standing narratives about globalization and efficiency. For decades, access to global markets was viewed as a stabilizing force that benefited all participants. What is now emerging is a more complex reality in which access is conditional and subject to policy decisions beyond corporate control. Even the most advanced companies must navigate geopolitical considerations that were once peripheral to manufacturing strategy. Tesla's experience should therefore be understood not as an isolated corporate issue, but as an indicator of structural stress within the U.S. industrial base. It demonstrates that vulnerability scales upward, not just downward. When foundational inputs are constrained, no amount of technological sophistication can fully offset the risk. The lesson is clear: resilience must be built into the system itself, rather than assumed as a byproduct of success. Restricted access to critical materials introduces a chain reaction that extends well beyond immediate supply shortages. The first visible impact is cost. When access becomes uncertain or constrained, prices rise, not only for the materials themselves but across the entire production process. Manufacturers are forced to compete for limited inputs, absorb higher procurement expenses, and rework logistics strategies. These added costs rarely remain contained. They move downstream, affecting pricing, profitability, and consumer affordability. As costs increase, innovation inevitably slows. Research and development depend on stable access to materials to test, refine, and scale new technologies. When supply becomes unpredictable, firms delay experimentation and prioritize short-term continuity over long-term advancement. Projects that rely on advanced materials are postponed or redesigned, often at the expense of performance or efficiency. Over time, this caution compounds, reducing the pace at which new products reach the market. Competitiveness suffers as a result. In global markets, manufacturers compete not only on quality, but on speed, reliability, and cost efficiency. When U.S. companies face higher input costs and longer production timelines than their international counterparts, they lose strategic ground. This disadvantage is particularly acute in sectors such as electric vehicles and renewable energy, where price sensitivity and technological momentum play decisive roles in market adoption. The effects also spill into labor and investment decisions. Rising uncertainty discourages capital investment in domestic manufacturing expansion, while higher costs place pressure on wages and employment stability. Investors, sensitive to risk, may redirect capital toward regions with more secure supply chains, further weakening domestic industrial capacity. What makes this dynamic especially concerning is its cumulative nature. Each disruption reinforces the next, gradually eroding the structural advantages that once defined U.S. manufacturing leadership. Cost pressures limit innovation, reduced innovation weakens competitiveness, and declining competitiveness undermines long-term growth. This cycle does not collapse industries overnight, but it steadily diminishes their global standing. In an economy increasingly defined by advanced technology and clean energy transformation, material access is inseparable from economic performance. When critical inputs become unreliable, the entire system operates under constraint, and competitiveness becomes harder to sustain in a world that rewards speed, scale, and strategic control. For decades, economic policy was guided by a belief that efficiency was the ultimate measure of success. Manufacturing strategies prioritized lower costs, just-in-time delivery, and global sourcing models that reduced inventories and maximized short-term profitability. These approaches delivered measurable gains in productivity and consumer prices, reinforcing the idea that open markets and specialization would naturally produce stability. What was overlooked, however, was the strategic cost of this efficiency-first mindset. As production migrated across borders, the United States gradually relinquished control over critical stages of industrial value chains. Mining, refining, processing, and component manufacturing were outsourced to regions offering lower costs or greater scale. Over time, this created deep structural dependencies that were invisible during periods of global stability. The system appeared resilient because it had not yet been tested by sustained geopolitical tension or deliberate supply restriction. This model assumed that market incentives alone would ensure continuity. In reality, it ignored the role of state policy, national priorities, and strategic leverage. When countries with concentrated processing capacity aligned industrial strategy with geopolitical objectives, efficiency-based systems offered little defense. Supply chains optimized for speed and cost proved brittle when confronted with export controls, regulatory barriers, or strategic stockpiling decisions. The consequences of this imbalance are now becoming clear. Industries built on complex, globally dispersed inputs lack the flexibility to respond quickly to disruption. Rebuilding capacity is not a matter of weeks or months. It requires years of investment, workforce development, and regulatory alignment. The efficiency gains of the past came at the expense of optionality, leaving manufacturers with fewer alternatives when conditions change. Policy choices reinforce this vulnerability. Industrial planning was often fragmented, with trade, energy, and national security objectives treated as separate domains. Manufacturing resilience was framed as a market outcome rather than a strategic responsibility. As a result, incentives favored outsourcing over domestic capability, and long-term capacity building was deferred in favor of immediate returns. What is now evident is that efficiency without resilience creates hidden risk. Systems designed to operate at maximum optimization lack buffers, redundancy, and adaptability. When shocks occur, the absence of these safeguards magnifies disruption rather than containing it. The lesson is not that efficiency was misguided, but that it was pursued in isolation, without regard for strategic exposure. The current challenges facing U.S. manufacturing reflect the accumulated effects of these choices. Strategic weakness did not emerge suddenly. It was constructed gradually, through policies that underestimated the importance of control, diversification, and long-term capacity in an increasingly competitive and politicized global economy. A renewed industrial strategy requires a shift away from reactive policymaking toward deliberate, long-term planning that treats manufacturing capacity as a national priority. The challenge facing the United States is not a lack of innovation or capital, but the absence of a coordinated framework that aligns economic growth with strategic security. Rebuilding manufacturing strength begins with recognizing that critical materials, processing capacity, and industrial know-how form the backbone of technological leadership. Domestic capability must be restored where it matters most. This does not mean replicating every stage of global production within U.S. borders, but it does require securing core functions, such as refining, advanced manufacturing, and material recycling. These activities provide leverage, flexibility, and control when external conditions shift. Without them, even the most advanced industries remain exposed to decisions made elsewhere. Strategic rebuilding is, therefore, an investment in autonomy rather than isolation. Equally important is the role of trusted alliances. A modern industrial strategy acknowledges that resilience can be shared among reliable partners. Strengthening supply chains across North America and allied economies reduces concentration risk while preserving the benefits of cooperation and scale. This approach replaces overdependence on single-country suppliers with diversified networks grounded in shared standards and mutual interest. Policy alignment is central to this effort. Industrial policy cannot operate separately from energy policy, trade policy, or national security planning. Clean energy goals, for example, lose credibility when the materials required to achieve them remain insecure. A coherent strategy integrates incentives, regulation, and investment to support long-term capacity rather than short-term market reactions. Public-private coordination plays a critical role, ensuring that government objectives and industry capabilities reinforce one another instead of working at cross purposes. Workforce development must also be treated as a strategic asset. Advanced manufacturing depends on specialized skills that take time to cultivate. Investing in education, training, and research infrastructure ensures that domestic capacity is not limited by labor shortages or technical gaps. Human capital, like physical infrastructure, determines how quickly industries can adapt and scale. Ultimately, A new industrial strategy is about redefining strength in a competitive global economy. It prioritizes resilience alongside efficiency, foresight alongside profitability, and long-term stability alongside innovation. By rebuilding critical capacity, diversifying supply chains, and aligning policy objectives, the United States can restore manufacturing leadership in a way that is durable, competitive, and responsive to an increasingly complex world. The question before us is simple but urgent. Will the United States continue to build the technologies of the future on supply chains it does not control, or will it reclaim the foundations of its industrial strength? Tesla's challenge today is America's lesson tomorrow. If we ignore it, we risk repeating the same mistake across every critical industry. If we act, this moment can become the turning point toward a more resilient, competitive, and secure manufacturing future. The era of complacency is over. The era of strategic manufacturing must begin now. Thank you.